Hello there everyone and welcome to this challenge on day 5. My name is Valentine and I'll be your instructor. In this challenge, we're going to be going through a set of Pandas library concepts that will allow us to be able to become better and better at working with the Pandas library for data manipulation, analysis, or for whatever tasks that you might have in mind in relation generally to data analysis. So let's get started. Before you get to this notebook, how do you access this notebook? So you need to go to the link in the description section. There's a practice resources link. Click on that link and it should take you to this page, a page that looks like this. And then you can click on this sample practice resource to be able to get access to the sample notebook that we're going to be using. If you're an Afterwork member, you will get access to the practice notebook. That's actually what I'm also going to be using. And that practice notebook will contain challenges for those sections that we haven't listed in the sample notebook. And again, if you want to continue practicing more, if you're new, consider becoming an Afterwork member and you get all the resources that you need when it comes to your learning journey. All right, so let's get started. So once you've gotten here, click on File, then save a copy in Drive, and a copy of this notebook will open in a new tab. And you can use that copy. You can close the original one and you can rename it however you want by double clicking the very top. For my case, I'll just go to the practice notebook and I'll open in playground mode. You don't have to. This is just because I don't want to make changes, and I also don't want to make a copy. But the concepts are still the same. So once you have created a copy and you're inside the sample notebook on your side, the next thing that you need to do is just to go to the prerequisite section and you're going to import the Pandas library. So let's do that. Just expand that and import the Pandas library. It's also important to mention, as this is happening, that you can always rewind the video, pause the video in the instances that maybe you might have gotten lost, or you can always rewind the video, pause the video to be able to get the most out of this learning experience. All right, moving on, the next thing that we need to do is now to go through the first set of concepts, the first concept. So we're going to learn how to filter data with multiple conditions. It's a concept that we've learned in the past. So let's load this data set. So this is the data set that we have. It contains patients' data. And if we want to filter for data based on multiple criteria, which of course allows us to just be able to extract specific records in order to be able to perform some analysis, we can then use the Boolean indexing approach. So this just means we would need to define just the conditions like as shown. So this is the first condition. We want to select the data from this data frame, which we have loaded, where age is greater than 50. And so we use an ampersand sign, and gender is equal to male. And also we would want to check for if any of those records, we would only want to work with the ones that contain the string disease. So it could be not necessarily exactly disease in terms of, for this particular diagnosis, it could be heart disease, like you can see here. So disease is a string inside this column. So inside this, it's a substring inside this string. So that's what we are doing here. We are specifying that we want to select the records with diagnosis that contains a string disease. So any other type of disease will be given this. So, and then we just store that in filter data and then display that. So you can see here we have these records, 4 records. One has Alzheimer's, and also the others have just heart disease. All right, at this particular point, pause the video and then work on the challenge. Moving on, we might want to standardize column names so that we can be able to work with them later easily, so that just generally for ease of consistency in our analysis, you don't want to be showcasing or how to retrieve records in your analysis using maybe column names that some of them are capitals, they have capital letters, others are a mix of capital and lowercase letters. Sometimes, in many cases, it's best practice to standardize them by simply having, say, one particular case. So for example, in our case here, we have this data set that we have here. These records, these column names are fine, but we can further standardize them by ensuring that they all have lowercase characters. And also for the column names that have multiple words, we can have instead underscores represent the space in between the words. So how do we do that? We first of all reference the column names by saying df.columns, and we specify that we want to use the lower function to be able to convert those column names into lowercase. And then we apply this other function, which it's a string function, which replaces any instance of a space, which would be the space between the words that that make up a column name, with now an underscore. So essentially what we're going to have at the end is that we are going to have column names which are which have lowercase characters, and also if there are more than two words within a column name, those two words will be separated by an underscore instead of a space. So yeah, so that's what we do here. We reference those column names and we apply those two functions, and then we replace now the original column names with now the new standardized column names, and then we display the change. So we should be able to see now the new column names that we have here. You could also do the f.head to just display the new data frame. So let me reload this and also reload this other one as well. And I should be able to see that have a new set of column names which have lowercase characters and an underscore between the column names with multiple words. All right, pause the video and then work on the challenge. We can also handle missing data in different ways. So one of the ways that we could do is to perform imputation. So replace missing values with, say, something like the mean of the values within that column, if that column is a numerical variable. So assuming that we have this data set, we can check for missing values as shown. So we use df that to reference the data frame, and then is null, and we also apply the sum function to count the number of missing values for each column. So here we have the missing values. So we can see in medication we have 18, in cholesterol, blood pressure, and weight we also have missing values. So once we have identified that, by the way, we could also perform some other operations before getting to the point of handling missing values. So it could mean that we might determine the data types for each and every column so that we know exactly the type of data that we are working with. Say, for example, in the weight column, we might not know that here, in this case, we might have something like, strings, and we would need to convert that into number, a numerical representation of that string. But in our case here, if you were to display this data set, you will see that we have just numerical data types, and you can check even the D type. So I've loaded this, and I can also check the data types by just saying df dot d types to just be d types to just be able to get the data types. And you can see that weight has float, height has integer. So our operation, the one that we want to perform on to handle missing values, is that we want to replace the weight a missing value with the mean of that particular column. So this is what we do. We ensure that we calculate the mean of the respective column, that's the weight column, and then so we say fill A, then we use the fill A function, and that function we give it two parameters. The first one would be not parameters, arguments. The first one would be the mean or weight of that column. So the mean value of that column, which is the mean of the weight column, and then we set in place to true to have this change be applied in the original data frame. Then we display the missing the missing values. So we can see for weight, which we have dealt with the missing values, the weight column has 0 missing values. So that's one of the ways that we could do, fill in with some reasonable number. Alternatively, what we could do we could decide to use, you could decide to drop all the rows with missing values in the data set. And initially, we could decide to do as shown here. We use the drop NA function, and we pass access is 0, and we want to specify how many missing values. So if any of the records have missing values, then we drop them. This just, when we set in place to true, just means we are applying the change to the original data frame. But normally by default, the drop NA functions has these set, so we do not necessarily need to set them. So you can just run these, and you should be able to get, now we've dealt with the missing values. They've been deleted, but you don't want to delete, in many cases, you don't want to delete the records. Maybe they could significantly affect your outcome. If you have some conclusions to make, like, if someone asks you what is the average age, and you've, in the records, you have maybe 50% of the records which don't have the age values, then in such a situation, you would need to figure out how to get the age value, maybe going back again to do another survey, because the conclusion that you make about the value, that's the average age, would need to be representative of the subject that you're talking about, or the subjects collectively that you're talking about. You can't just say the average age of this particular population without having considered the entire population. So yeah. Pause the video and then work on the challenge. Coming back to filtering, we can also perform index. Again, we can also perform Boolean indexing. So this is just a quick refresher of what we've done in the past. So this is our data set that we've loaded, and then we can decide to filter for data where the gender is equals to female, so that we have just female records. Records with just the value female for the gender column. So we do that as shown here. So we set our condition to what you see here, and then we store the outcome of or those records, that's female patients, inside the female patients variable, which still is a data frame. And then we can sort by age. So once we have applied this filter, once we filtered the data set, we can sort by age. So in this case, we can sort by age, and then we would want to sort in ascending order. If we set this to false, it would be in descending order. So we use the sort values, and we pass it, give it these values to be able to sort by whatever variable, and in whatever approach that we want. So yeah, so let's run this, and we should be able to see now our outcome. So we have female patients sorted by age. So you can see 25, 25, 25, 28, 28, 32, etc. Right, pause the video and then work on the challenge. Statistical analysis with pandas. Sometimes you might want to perform some statistical summary, just be able to get all the information that we need in terms of statistical aspects, maybe mean, mode, etc. Well, not everything. We would get some essential, some basic statistical measures for the respective data sets that we have. So let's load this data set, and how we can be able to, so this is the data set, how we can be able to get the, say, summary statistics. So in our case over here, we're actually going to only get the summary statistics for the numerical columns, which are only 2, but we can always apply this same function to whatever data frame that we have, and it will give us the statistical summary of the numerical variable. So this can be just an entire data frame, or it can also be a summary table that we've generated from a pivot, from a group by function, so from another table. So this is one that gives us the summary statistics of the numerical variables within our data frame. So it will actually consider patient ID and age. Patient ID may not be important, but age might be important. So if we run this, we should be able to get some summary information about those 2 numerical variables. And you can see count, which can tell us missing values, the mean, tell us about central measures of central tendency, which is one of the measures of central tendency. We also have standard deviation, a minimum, maximum value, etc. So we can also do the same thing to a pivot table or a summary table, which you can see here. So here we apply, so if I am to okay, you could still do the same thing, but here we are able to get the summary statistics for gender. That's the gender versus age. So for gender, let's say the count is okay, but for mean, like you can see that for female, the mean age was 45.5 and mean for male was 43.3, standard deviation, etc. All right, pause the video and then work on the challenge. Data filtering with iLoc. So we've learned how to filter data through Boolean indexing. We can use also a query function of query method, which we'll get to learn about. So for some sort of advanced way of filtering, we can decide to use what is called iLoc slicing, which allows us to extract specific rows and even columns that we want. So let's load this first. So this data set, this is how our data set looks. And if you wanted maybe to extract specific rows, let's say we wanted to extract rows, this second row to row 5. This is row to row 5. Yes, to row 5. So these ones. So if you wanted to extract just these records, but again, we don't want all the column names. Maybe we wanted to only extract column 1, that's patient ID. We also wanted to extract gender, age, and diagnosis. Then we would need to use positions for those columns, as well as rows. So we can start by, first of all, defining, referencing the data frame that we had, df, then we use iLoc, then square brackets, then we specify initially the rows and then comma columns. For rows, we specify that we want to get our rows from index 1 to index 5. So row 1 to row 5, and then we can also specify columns. So column 1 to column 4. For this particular case, we would need to we would get 4, the fourth particular column that's here. Actually, essentially, we also, when we specify 5, we are going to get the fourth, the one that has an index 4. So in our case here, we would get this particular column. So whatever that you're finishing for both ranges that you have here, the ones that you're specifying, we'll get the previous value, whether it's for the rows or for the columns. Then we display the filter data. So you can see that's what we are getting. Pause the video and then work on the challenge. At times you might have some some condition that we might want, and that might involve working with dates. So how are we able to work with dates? So essentially, we might want maybe to get information about patients who were admitted between a specific date. So what we need to do is to get, first of all, the data. Then once we have gotten the data, the next thing that we need to do is to convert the columns the date columns into a date time format. And then once we have done that, we can now perform Boolean indexing and apply just those conditions that we want. So in our case here, this is what we do. Once we've loaded the data set, we want to work with admission date because we want to get patient records within a specific admission date. So so that's what we do here. We convert the admission date using date time. We want to convert it to a date time format so that we can work with a date type of data. It's like the way you'd work with integer type of data. You convert it maybe from string to date to integer, or integer to float, etc. Then once we do that, we define the start and ending date. So here we have 2023 January 1st, and here we have 2023 December 31st. So, and then we filter the data. So we use just Boolean indexing. We specify our first condition, which we have here, where the admission date is greater than or equal to start date. And end, we use a number sent, where admission date is also less than or equal to the end date. And then we display the filter data, which we have here. So if you look at the dates over here, they're all in between the specified range. All right, pause the video and then work on the challenge. In some cases, we might want to filter for data in an easier way. So Boolean indexing is one of those approaches, but we can also decide to use the query method, which allows us to efficiently filter large data sets. And yeah, so let's load this data set, which will display here. And then once we have done that, we can then decide to apply our conditions. So we can say, we want to get records where diagnosis, so diagnosis is equals to diabetes. So what we do is just apply the query method to the data frame, and then inside the query method, we just specify our condition. So for this, we want diagnosis is equals to diabetes. And that's it. We display now the diabetes information. Yeah, so alternatively, if we want to have multiple conditions, we just use an AND. You can see an AND keyword inside our condition, and yeah, so that's it. So here we're selecting for records where gender column has the male value and age is greater than 50, and we display that. We have quite a large number. Pause the video and then work on the challenge. Moving on, so here we've learned how to, in the previous one, we got to learn how to work with query and also date range. Which one is it? iLoc. So there's iLoc. iLoc allows us to use positions, which are numbers, but we can use now the loc slicing method to be able to specify, say, the columns. So you remember where in iLoc we specified here as iLoc, but here we had rows and here columns. So instead, with the loc slicing method, we can specify the columns using the column names themselves. So a label. So the column name, we can use it. But if we had iLoc here, we would use now the positions of those records, those columns instead. So iLoc, that's where the big difference comes in. And also with iLoc or loc, you can also specify the specific condition that you want. So for example, where we were using Boolean indexing. So in our case where we were using Boolean indexing, I'm just trying to look like here, we could always you can also pass this to loc. So here, instead of saying that this just means we are selecting all the records, we could always even specify some condition where gender is equals to female. That's the beauty with also, the loc method. But again, this is slightly different from using just Boolean indexing directly, because with this method you can you can specify the column names that you want and the rows. But if you use Boolean indexing, you would then later onwards need to set the specific records in a new line of code that you want. So you would need to reference the column names that you want from the generated data frame from Boolean indexing. So you'd have like two steps, but with loc method you have only just one step. So in our case here, we're just selecting just all the records and we are selecting the specific column names. You could use this method, but this you can actually achieve this differently. Because this is just practice work, you can even just, instead of specifying that you want to select all the records, you can even just say that this is actually equal to, it will give you the same result as this. Because you're just now selecting all the column name values, these column names and their respective records. But this would also give you the same outcome. Okay, let me reload this. Sorry. Oh, and also put loc there. All right. All right, pause the video and then work on the challenge. Lastly, data loading optimization. So this is a concept that's quite popular in data engineering. So sometimes we might want to efficiently write our code. By default, you can write Pandas code as you would want, especially when you are importing data. So you can import data. Like in our case here, we are importing this data set, we are storing it in df. So we are just taking the entire data set and boom, reading it all entirely and putting it in df. And once we do that, we could decide to display the information. But here we are using .info to display just some memory information, like how much memory was allocated to this particular data frame that we read it all at once. So if I load this, I should be able to get information about memory consumption. So you can see here, memory usage was 42.3 KB. If you don't set aside memory usage, you won't get the specific, you'll get an estimate, 43 point something KB, but here you get 6 point something KB. But if you use memory usage is equals to deep, you get more information about the specific storage or memory allocation, that size of memory allocation that was given for this particular data frame. So this is one approach, and which is what it works efficiently. But if we have large data sets, sometimes we might want to perform our operations, especially when we are reading a lot of CSV files. We would want to do it efficiently, considering that if the code that you're going to be running will be running on the web, and you need to ensure that you don't spend a lot of storage costs, because some billing sometimes happens when it comes to how much memory that you're consuming when it comes to your application. So this is just one ways of you can optimize your code. So instead of just loading your data like this, so you can decide to specify the specific column names, data type, the data types for the specific column names. Like here we have patient name object, patient ID int 64, age int 64. And when you look at age can only carry, say, a number like 0 to 120 or 130, and that's it. But you may not necessarily need to allocate an entire, you may not necessarily need int 64, which actually specifies that you allocate a whole lot of space, memory space. So what you could do is to use maybe another specific data type like int 8 or int 16 that would work well with the data that you're working with. And this depends with whatever data that you have. So how to do we do that? So we create a dictionary and we specify the column name that we want to replace the data type for. Like, say, for example, patient ID will be a key would be the key for one particular key value pair. So key, and that's patient ID, wanted to have int 32, and for age you wanted to have int 16. So we store that dictionary. Those are the two modifications that we want. We store it in D types. Again, here URL, we're just storing it in URL, but you can always just pass it to read CSV. And then what we are going to be doing is to be loading this data set, not entirely, but in chunks. Like, we can split this data set into specific chunks. We can even decide maybe to split it into 10 chunks, 100 chunks, for faster processing. That way we are able to load the entire data set. And you might realize if you get to work with maybe gigabytes of data, maybe a CSV file that's in the gigabytes, if you try to load it maybe on Google Colab or Jupyter Notebooks, you might get a lag. So sometimes you might want to load it using this particular approach. So you still use the read CSV function. You pass the URL or the location of your file and then file name. And then we specify the new types of data, the new data types that we want to apply to. So these are the new data types that we want to apply. And then we set the chunk size. Here we just set it to 1,000, which would technically split our data into 1,000, but it's not that big. We can even set it to 100 or even 50 or 10, etc. Then once we do that, we can then decide to, once we have the chunks here, we can then concatenate those chunks. So we join those chunks into one particular single data frame, and then we display the data frame. So if I load this, I'll still be able to load the data set, as you can see here. But if I display the memory information, you'll get to see that of this just same data frame, memory is 41.6 kilobytes, but here we have 42.3. So 41, it's slightly little, but when you are working with large data sets, you'll realize that you're actually saving a lot of memory. And this is again for just practice purposes. Right, pause the video and then work on the challenge. Right, so that's it with regards to this challenge. So I hope you're able to learn a few things, a few important things, and are able to get better and better. So the idea again is to just get better at being able to use the Pandas library when it comes to performing data analysis tasks. And of course, we'll have more challenges and will be a bit more repetitive, but the idea is, again, once you do something over and over, like, it's like running. If you run every day, at the end of it, or at the end of maybe a specific period, maybe 6 months or you will see now the results, and over time you'll also get to see the results. If you liked this learning experience and if you found it valuable, be sure to give us a thumbs up. It tells us that we're doing a good job. And if you'd want to be informed when we post such future challenges, be sure to subscribe. Bye bye, and see you in the next challenge.